All right. Fingers crossed. It says stream is happening. Okay, I'm live on Twitch and I'm live on YouTube. Yes, excellent. Oh wow, that's a lot of copies of my voice happening at once. Let me just tweet about it and then we can jump on in. Hello everybody, welcome. If you've been following the live streaming saga, I've been having a lot of technical difficulties and they are now resolved, and we've got a camera, which was actually set up before my GPU died, and then it did not happen for reasons that are maybe obvious. And let me adjust this window so I can see the chat better. Hello everybody, Jer, Merdad, Mr. L, welcome. I am delighted to be all good to go again. Okay, so let's jump right in. Let me pause these actually so I don't get any problems with latency. So we've been reading the GPT-2 paper, Language Models are Unsupervised Multitask Learners, which is, oh, one sec, let me move my mic. It's quack. There we go. Now I can pick up my keyboard sounds. Really good. It's a cardioid mic, which means that the good shape for you to be in is like heart shaped, starting at a phone in my apartment. It was me. I'm sorry. I for some reason turned off Do Not Disturb at some point, like a Gen Xer. Okay, there we go. Sorry, I didn't mean to make digs at Gen X. I just don't believe in phones. So many people. Hello, welcome. So, we've been reading through the GPT-2, oh, I don't need to be on Twitter no more, GPT-2 paper, Language Models are Unsupervised Multitask Learners. This is the third week that we've been working on it, and I think we are up to section, we were in the experiments. We definitely did the Winograd Schema Challenge because I had lots of thoughts about that. We talked about, did we talk about Coca? F1 and then comparing it to BERT, summarization. Yeah, I think we got through summarization, so up to section 3.7. And I've been doing lots of thinking about this paper. Yeah, I'm gonna save my thoughts to the end because I want to finish reading the paper in depth and give it a really fair shake and not just like talk about all my thoughts now until I've actually, done the reading. Sorry, a little bit of coffee. I'm gonna try really hard not to slurp in the mic. So they did a bunch of tasks. And if you were wondering where the rest of the description of the language data set that they put together is, which seems to be the main contribution of this paper, so like the core thing that they did that they would like credit for, it seems like that little section that we had up top is pretty much it, but there's going to be a little bit more discussion in the translation section, maybe someone mentioned last week, so yeah, we'll see. So let's restart through the summarization section. So we test GPT-2's ability to perform summarization on the CNN and Daily Mail dataset. That's CNN, not a convolutional neural network, so it's like the American News Network. So Mom says, are you not going for TensorFlow Dev Summit? I am not. No, I've got a lot of travel coming up. I'm going to be at the Open Science AAAI conference at Stanford in a couple weeks. I'm going to be going to the University of Indiana for a workshop and a talk. I'm going to be in a bunch of different places. I'm going to be at NACL, of course, in Minneapolis in May, in the future. I will be there. It's on my calendar. I just got a lot of travel, so I'm not going to be at the Dev Summit. Okay. To induce summarization behavior, we added TLDR after the article and generate 100 tokens with top K random sampling, Fon et al. 2018. With K equals 2, which reduces repetition and encourages more abstractive summaries than greedy decoding. And I believe K is like a temperature measure, so you get like more varied outputs we talked about last time. We use the first 3 generated sentences in those 100 tokens as the summary, so they just sort of like arbitrarily pick an ending point. Well, qualitatively, the generations resemble summaries, so it's learned something about like the style of summaries from TLDRs. I showed in table 14, they often focus on recent content from the article or confuse specific details such as how many cars were involved in a crash or whether a logo was on a hat or a shirt. On the commonly reported Rouge 1-2L metrics, the generated summaries only begin to approach the performance of classical neural baselines and just barely outperform selecting 3 random sentences from the article. This suggests that maybe this is not a good approach for this problem. Like, if you're not doing quite as good as random, if you're only doing like slightly better than random, why did you spend the time training the model and the money? Yeah, it's a big model. It took like a lot of time and compute. GPT-2's performance drops by 6.4 points on the aggregate metric when task hint is removed, which demonstrates the ability to invoke task-specific behavior in a language model with natural language. Maybe. Or maybe you have a language model, so it does better if you give it something to begin its generation in. And then translation. We test whether GPT-2 has begun to learn to translate from one language to another. In order to help it infer that this is the desired task, okay, so a language model doesn't really do inference. I know what they mean. They're being like, what's the word? They're not being like, poetic necessarily, but they're being, you know, I don't think that they think that they're actually doing inference. I think it's just the turn of phrase that they're using. We condition the language model on a context of example pairs in the format English sentence, French sentence, and then after a final prompt of English sentence, we sample from the model with greedy decoding using the first generated sentence as the translation. On the WMT14 English-French test set, GPT-2 gets 5 blue, which is slightly worse than a word-by-word substitution with a bilingual lexicon inferred in previous work on unsupervised word translation. Kanyu et al. 2017 B. It's worse than a rule-based system that took like a dictionary. I could write a rule-based word-by-word substitution system in 5 minutes. Maybe not at 5 minutes if I was using Python, because I'd probably have to look some stuff up. But that's like very simple, right? It just doesn't take a lot of time. You do have to have a big bilingual lexicon, though. Those exist, especially for French and English. On the WMT14 French-English task set, the GPT-2 is able to leverage its very strong English language model to perform significantly better, achieving 11.5 blue. And if you are familiar, blue, metric, treble, medium, I wrote a, I wrote a very, in-depth blog post about blue and why it's got some problems and why it's maybe not necessarily the best choice for so it is one of the more commonly used metrics for corpus level translation, but because they're doing this at a sentence level, you shouldn't be using blue at an individual sentence. That'll artificially inflate the score. And also blue doesn't consider meaning, as their model doesn't, so perhaps it's giving this sort of unsupervised model a, not necessarily an unfair advantage, but it doesn't consider the thing that I think is the most important about translation, which is that you get the content, like the semantics of the transferred information is the same. I mean, semantics is language specific, but the sort of information content is the same between the translated versions. So anyway, that's my blue rant, which I go into much more detail in the blog post, so I'm not gonna talk about it here. This outperforms several unsupervised machine translation baselines from both of them from 2017, and I don't know that I'm super familiar with either of these works. I'm not very deep in the neural translation literature, So I will leave commenting there to people who know more. Performance on this task was surprising to us since we deliberately removed non-English web pages from web text as a filtering step. In order to confirm this, we ran a byte-level language detector on web text, which detected only 10 megabytes of French language, which is approximately 500 times smaller than the monolingual French corpus common in prior unsupervised machine translation research. CLD2. This is not a language lang ID program that I'm particularly familiar with. Splitzking on Twitch says hello. Hello. Oh, that's the other thing. Since I have my system set up, I can do Twitch and YouTube at the same time now, which is nice. So, looking at lowercase Unicode letters and marks after deleting digit punctuation tags. Okay, so basically it's looking for, well, I'm not super familiar with this algorithm. Language identification is hard, and it's really hard on short text, and it's really hard on text which is informal and might have code switching, so you might have multiple languages together. So web text, for example, if you've spent much time on Twitter and you're multilingual, you've probably seen a lot of like examples of, tweets that have multiple languages in them at the same time. And I think I wrote a kernel on that a minute ago. Let's see. Multilingual in kernels. Gotta spell it right. Yeah, so I wrote a kernel about this a while ago. And I talk about some different language models. We did Spacey, which is sort of a large production library, or production ready NLP library. And at some point I figured out like the percentage that were correct, I believe. Well, anyway, somewhere in there I talk about it. And the point is that automatic language identification is a very lossy process. So I don't know that they only had 10 megabytes of French data, especially if they're doing something like looking for character level models. So if I'm working on a keyboard that doesn't include diacritics and I'm doing French, I'm gonna probably leave the diacritics out, which might make a character level model less good. Oh, sorry, byte level. But it was byte level of the Unicode code point, so that would include diacritics. Okay. And that's all they said about translation. I guess the point that they're trying to make in this paper is that this model works good for everything, but like, does it? Like, it sounds like there's several tasks that they've talked about where the GPT-2 model is not performing above chance for a randomized baseline. So for like machine translation, it's not doing better than, it's not doing that much better than just like a word-by-word substitution. For summarization, it's not doing much better than just picking 3 random sentences. And at least the 3 random sentences from the thing you're summarizing are gonna have the correct information from the thing you're summarizing, unlike this hallucinated language output that includes like changed facts, like the number of cars that are involved in an accident. That's really important, especially if you're doing maybe legal things. So, that's where I am at that point. And then question answering. Oh, and it looks like they have some, okay, so these are output from the question answering, so I'll zoom into those when we get going. 3.8, question answering. A potential way to test what information is contained within a language model is to evaluate how often it generates the correct answer to a factoid-style question. Is that is that information? Like, it's definitely like a non-random process because language is always non-random. There is nothing random that occurs in human language. It's always structured. I don't think that they're right. I think that that whole sentence is wrong. That's what I'm getting from that. Previous showcasing of this behavior in neural systems, where all information is stored in parameters such as a neural conversational model, reports qualitative results due to the lack of high-quality evaluation data sets. So they're saying that they're just sort of like reporting how well they think that they did based on just like looking at it because there weren't a lot of data sets available. The recently introduced Natural Questions dataset 2019 is a promising resource to test this more quantitatively. There have been a lot of question answering datasets that have come out between 2015 and 2019. Like, I'm not in the space, and there's a lot. And isn't Coca a question? Yeah, Coca is a question answering dataset. I mean, like, it's based on additional information, like you get the text, but okay. Similar to translation, the context of the language models is seeded with example question pairs, which helps the model infer the short answer style of the dataset. Okay, I get that you're learning something like templatic. Not templatic, I don't think that there's like template level understanding, but definitely like stylistic things I'll buy. GPT-2 answers 4.1% of questions when evaluated by the exact match metric commonly used on reading comprehension data sets like SQuAD. Ooh, that's low. As a comparison point, the smallest model does not exceed the 1% accuracy of an incredibly simple baseline, which returns the most common answer for each question type: who, what, where, etc. GPT-2 answers 5.3 times more questions correctly, suggesting that model capacity has been a major factor in the poor performance of neural systems on this kind of task as of yet. Are they arguing that like 4.1% is good? The probability GPT-2 assigns to its generated answers is well calibrated, and GPT-2 has an accuracy of 63.1% on the 1% of questions it is most confident in. Did they have any way of guaranteeing that those questions weren't in the training data? I'm not entirely sure where the natural questions dataset is coming from, but if it's coming from like Wikipedia at all, like I know they said that they removed the Wikipedia portions, but people quote Wikipedia, and there are also websites that are just like straight up Wikipedia text on a different URL. Not that they're like mirroring, but they just like copy pasted Wikipedia text to get more traffic, I guess. I don't know. So they should definitely check that the questions that they're answering aren't actually in their data set. And I know that they said that they have evidence that it didn't memorize stuff, but did it not actually? The 30 most confident answers generated by GPT-2 on development set questions are shown in Table 5. The performance of GPT-2 is still much, much, much worse than the 30 to 50% range of open... sorry, that third much was me. They just said much, much. Open domain question answering systems, which hybridize information retrieval with extractive document question answering, Alberti et al. 2018. It turns out having any model of meaning at all makes question answering better. Alec, who previously thought of himself as a good at random trivia, answered 17 of 100 randomly sampled examples correctly when tested in the same setting as GPT-2. He actually only got 14 right, but he should have gotten the other 3. So something that has been increasingly annoying to me as someone who knows and has studied human behavior, specifically around language in depth, is this idea that, like, human behavior is a single baseline. Human behavior, like human levels of performance, right? That's the thing that we want. Human levels of performance vary wildly. So like my human level of performance in question answering in French is gonna be like real bad because my French ain't good. Like a little bit. So if you're targeting my question answering ability in French, it's fairly easy to build a model that can do as well. But if you're targeting the behavior of someone who, say, you would pay to do the task, that's a pretty divergent set of things that you're trying to match, right? All right, let's see some of the examples. Anyway, my point is that just like having a footnote about like how good one random person did on a task is not a good measure of human performance. And I get where they're going from, where they're coming from this, and I think it's like a cute footnote, but also like, you have a sample size of 1, my dude. Okay. Who wrote the book Origin of Species? Charles Darwin, correct. Probability high. Who is the founder of the Ubuntu project? Mark Shuttleworth, correct. Probability high. Let me zoom in a little bit because these are very small. Additional information. So there's just a bunch of questions. The most common blood type in Sweden, they generated A, and that is incorrect. Excuse me. Mute the mic in time. Sorry. Okay, so it's a bunch of questions that they have generated answers for, and I'm guessing that these are the ones with the highest probability answers. The 30 most confident answers generated by GPT-2 on the development set of natural language questions, sorted by their probability according to GPT-2. None of these questions appeared in web text as described according to the procedure described in section 4. Okay, so how did they test for data that was overlapping? Wait, section 4? Okay, we haven't got to there yet. All right. So they'll talk about that in a little bit more depth. Oh, they did the thing where related work is at the end. I hate that. Hate it. I know it's common in some fields. Drives me nuts. I want to know about the related work first. Otherwise, I don't know what your contribution is. Okay. Okay, so they're saying that they're not, not memorizing these questions. They haven't seen these particular questions before. Okay. I'm still... Yeah. Jara says, yeah, usually related work goes in the first part to put you in context. Right. I like that. I think specifically for like medical trials, sometimes you'll have related work after because the point is like, here's what we did in the trial. And they're trying to get to like doctors who are super busy, and that I kind of get. But I like it in the front, especially for something where like you're claiming to have really transformatively done things in a field. Anyway, so far where I've gotten from the non what do they call this group of tasks? So they call this the experiments, and then they talked a little bit about generalization versus memorization. So this must be the quality of the model. So the thing that I've gotten about their model based on all of the different experimental tasks that they talked about is like, it's not, on very few of these tasks is it better than like a reasonable baseline. And like a baseline that would be very cheap to train and do and implement. And this is I don't think they talked about, when they talked about blah, 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 transformer. Yeah, it looks like they didn't talk about training time or cost or, how long it took, but it's a big model. Like 1.5 billion trainable parameters is a lot, and you're updating those every pass. That's a lot of compute. That's a lot of time. That's a lot of electricity. There's an environmental impact of that. Like, is that really much better than just picking 3 random sentences or just doing word-by-word substitution, which you can do much more cheaply and easily? And I think that the point that they're trying to make with all these experiments is that it doesn't completely not work on any of the tasks, but it's also not doing good, and it doesn't hold even state-of-the-art in pretty much... Were there any tasks where they explicitly were like, we've got state-of-the-art? say zero sought results on many data sets. No training or fine-tuning was performed on any of these results. Perplexity. So I think that they're saying that they're claiming that they got pretty good results on these things, which are just based on language modeling. Yeah. Okay. So they're saying that this is a state-of-the-art language model specifically. But when... And then they also, on the children's book test, Lambda dataset, long-range dependencies. They increased the state-of-the-art, but they also use different pre-processing, so it's not exactly apples to apples. Wino Grad Schema, they did not do good. Coca... Oh, one sec, there's a comment, but the chat is too small for some reason. Oh, I'm scrolled down. Ryan says, the translation was good for being unsupervised and given how little data they had in other languages. I don't think they explicitly claim state-of-the-art in anything, though. Yeah, so it's kind of crappy at everything, but it's not horrible at everything. Like, you get like a little bit of benefit of not having to do the task-specific thing, I think is what they're claiming. But I'm not like blown out of the water by any of these results, and some of them I'm just like, okay, like I wouldn't do it that way. And it was a big model that took a lot of time and data to train. Yeah, I think that this is useful in that it is a current high watermark for how far you can currently get. I said current twice. Just like throwing spaghetti at the wall, just like a bunch of data, a bunch of stuff, a bunch of parameters, training for a really long time, big model, really, really big text data set. What can you get? And the answer is like no good model of meaning. Jaredus says, if you're in a hurry and you want to get this done in a month, then you're going to need 80 GPUs. You can always grab a server with 8 GPUs from AWS Spot Marketplace for $7.35 an hour. I think I'm going to go out on a limb and said that they spent a lot of money on this. And maybe they had the tech lying around. I don't know. But yeah. And also, you're also going to need a data set, and they didn't release web text, and people have been trying to reverse engineer web text to limited success is what the sort of like current Twitter milieu seems to be. Jared says that's around $53,000 a month. You'll need 10 servers, so that's around $50K to train the model in a month. Again, it would take me 5 minutes to do like a word-for-word substitution cipher for machine translation. And it's also reliant on you having a really big text data set. And for a lot of languages, you just don't have that. Like, there's just not that much text available in a computer-readable format. So, like, I don't know how big of a text data set you'd be able to get of Thai, for example, but not that big. I would be surprised. So, Jara says, that's an estimate by Jeremy Howard. Helpful. And Ryan says, that's a drop in the bucket for OpenAI. That's true, but I mean, if we're reading NLP papers as practitioners, we want to know things that we can do and we can apply. And if they'd also released the full model, then I could see more of the argument, because it would be like, we spent all this time and also anybody could use it, but they didn't. They released the partial model. Anyway, so let's keep reading there, because I haven't actually read their rationalization for only reading the partial model themselves. Generalization versus memorization. Source says, hi. Recent work in computer vision has shown that common image data sets contain a non-trivial amount of near-duplicate images. For instance, CFAR10 has 3.3% overlap between train and test images. Oh, they got leakage. This results in an over-reporting of the generalization performance of machine learning systems. As the size of tech datasets increases, this issue becomes increasingly likely, which suggests a similar phenomena could be happening with web text. Therefore, it is important to analyze how much test data also shows up in the training data. Okay, I'm glad they're addressing this. To study this, we created Bloom filters containing 8 grams of web text training set tokens. To improve recall, strings were normalized to contain only lowercase alphanumeric words with a single space as a delimiter. The Bloom filters constructed were such that the false positive rate is upper bounded by 1 over 10 to the 8th. We further verified the low false positive rate by generating 1 million strings, of which 0 were found by the filter. Okay, so they're saying we just generated some random strings and looked to see if our filter found them, and it didn't. Honestly, I'd be okay with a lower false positive rate because you're looking for things that are very similar. And also, I'm not super familiar with Bloom filters. Let's check those out. Not something that I have previously encountered, or at least not by that name. A space-efficient probabilistic data structure conceived by Burton Howard Bloom in 1970 that is used to test whether an element is a member of a set. Yep. False positive matches are possible, but false negatives are not. In other words, a query returns every possibility in a set, either possibly in a set or definitely not in set. Elements can be added to the set, but not removed, though this can be addressed with a counting filter. The more elements that are added to a set, the larger the probability of false positives. Okay, so the reason that they're worried about false positive rates is because it is more likely with this particular type of model. I'm a little bit interested in the algorithm description. An example of the Bloom filter representing the set XYZ, the colored arrows show the position in a bit array that each set element is mapped to. The element W is not in the set XYZ because it hashes to a 1-bit array position containing 0. For this figure, m equals 18 and k equals 3. A bit array of m bits, all set to 0. There must also be k different hash functions defined, each of which maps or hashes some set element to one of the m array positions, generating a uniform random distribution. Typically, k is a constant much smaller than m, which is proportional to the number of elements to be added. The precise choice of k and the constant proportionality of m are determined by the intended false positive rate of the filter. Okay, and because it is byte-wise, I believe they said. I think everything they did was byte-wise. Nope, it's 8 grams. Okay, so they're looking to see unique 8 words together. That seems a bit high, but you definitely want to avoid like 3 grams, because 3 grams would have like something like of the next, and that's probably gonna occur a lot, or on the table, probably gonna happen a lot in a general text corpus. So yeah, okay, interesting. These Bloom filters let us calculate, given a data set, the percentage of n-grams from that data set that are also found in the web text training set. The table 6 shows this overlap analysis for the test sets of common LM benchmarks. Common LM datasets test set have between a 1 to 6% overlap with web text train, with an average overlap of 3.2%. Somewhat surprisingly, many datasets have larger overlaps with their own training splits, many with an average of 5.9% overlap. Okay. One approach optimizes for recall. Our approach, optimizes for recall, and while manual inspection of the overlap shows many common phrases, there are much longer matches that are due to duplicated data. This is not unique to web text. For instance, we discovered that the test set of Wikitext 103 has an article which is also in the training dataset. Since there are only 60 articles in the test set, that is an overlap of, there is at least an overlap of 1.6%. Potentially more worrying, 1 billion word corpus has an overlap of nearly 13.2% with its own training set according to our procedure. For the Winograd Schema Challenge, we found only 10 schemata which had an 8-gram overlaps with the web text training set. Of these, 2 were spurious matches. Of the remaining 8, only 1 schema appeared in any context that gave away the answer. A significant portion of additional overlap is due to editors reusing some paragraphs across multiple articles with a shared theme, such as various battles in the Korean War. For COCA, about 15% of documents in the news domain are already in web text, and the model performs about 3 F1 better on those. COCA's development set metrics reports an average performance over 5 different domains, and we measured a gain of 0.5 to 1 F1 due to overlap across various domains. However, no actual training questions or answers are in web text since COCA was released after the cutoff date for the links in web text. That's okay, so if the dataset was released after the dataset that you are releasing, that doesn't mean that they don't have overlapping data. Ryan says, to be honest, just not impressed by transformers in general. I don't think they're the way forward. Yeah, like I said, I have a lot of thoughts on this paper, but I'm gonna save them for the end. However, no actual, blah, blah, we read that. On Lambda, not Lambda as I keep reading it, the average overlap is 1.2%. GPT-2 performs about 2 perplexity better on examples with greater than 15% overlap. Recalculating metrics when excluding all examples from any overlap shifts results from 8.6 to 8.7 perplexity and reduces accuracy from 63.2 to 62.9%. This very small change in overall results is likely due to only 1 in 200 examples having significant overlap. Overall, our analysis suggests that data overlap between web text training data and specific evaluation datasets provides a small but consistent benefit to reported results. Shocking. However, for most datasets, we do not notice significantly larger overlaps than those already existent between the standard training and test sets, as Table 6 highlights. Okay, but that's like, well, we found it with other people, so it doesn't matter if we do it. I mean, just, you have an efficient way to find the overlaps, just get rid of them. Remove them from your training data if you know that you're going to be testing on these data sets. Or maybe they train their model and then we're like, let's go shopping for valuation data sets, which I'm getting the feeling might have been their particular procedure here. Overall, our analysis suggests, oh yeah, we already read that. Table 6 highlights. And here they talk about the overlap. So there's more overlap in the Penn Tree Bank. Okay, so on 2 of the datasets, there's more overlap with WebTrain. On 4 of the datasets, there's more overlap in the dataset training as opposed to the evaluation datasets, using their 8-gram measure. Understanding and quantifying how highly similar text impacts performance is an important research question. Better deduplication techniques such as scalable fuzzy matching could also help better answer these questions. For now, we recommend the use of n-gram overlapped-based deduplication as an important verification step and sanity check during the creation of training and test splits for new NLP datasets. I'm fine with that, yeah. Another potential way, also they kind of didn't do it, another potential way of determining whether the performance of web text LMs is attributable to memorization is inspecting the performance on their own held-out set. As shown in Figure 4, performance on both the training and test sets of web text are similar and improve together as model size is increased. This suggests even GPT-2 is still underfitting on web text in many ways. GPT-2 is also able to write news articles about the discovery of talking unicorns. An example is provided in Table 13, which is probably one of the things you might have seen floating around Twitter. Did they talk about their own overlap with their own test set? I don't see it. That doesn't mean it's there. Not there. Okay, let's talk about related work. A significant portion of this work measures the performance of larger language models trained on larger datasets. This is similar to the work of Jasofowicz et al. 2016, which scaled RNN-based language models on the 1 billion word benchmark. LMs as a function of model size. Train. Test. Okay, so they have lower perplexity, which is better on their training data set than their testing data set. And as the model size gets bigger, they begin to, they both decrease. Although those, that last number of parameters, it looks like it might be starting to diverge a little bit. So I don't know. I personally, assuming that these were reasonable numbers, I might not keep training a model with more parameters at this point just because it looks a little, I don't know. I don't know if you guys think like that looks like it's diverging. I think it does. Yeah. Anyway, sorry, I'm feeling feelings. Bajigger et al. 2016 also previously received improved results on children's book tests by creating a much larger training dataset out of Project Gutenberg to supplement the standard training dataset. Hessness et al. 2017 conducted a thorough analysis of how the performance of deep learning models changes as a function of both model capacity and dataset size. Our experiments, while much noisier across tasks, suggest similar trends for holding subtasks of an objective and continuing into the 1 billion plus parameter regime. Let's go with regime. Okay, so they're saying other people did big things. We found that bigger is better sometimes on some tasks. Ryan says, it is diverging, but test performance is still decreasing. Might as well go straight to 10 billion and see what happens. Yeah, I'm sure that they're training that model even as we speak. Interesting learned functionality in generative models has been documented before, such as the cells in an RNN language model performing line width tracking and quote comment detection in Carpathy et al. 2015. Ooh, that I have read. More inspirational to our work is the observation of Liu et al. 2018 that a model trained to generate Wikipedia articles also learned to translate names between languages. Okay. Previous work has explored alternative approaches to filtering and constructing a large corpus of web pages, such as the iWeb corpus. That's the only web corpus you're gonna cite? Okay. There's a lot of web corpuses. If you're unfamiliar, there's a whole field called corpus linguistics that generates and analyzes corpora. There's a lot of web corpora. There has been extensive work on pre-training methods for language tasks. In addition to those mentioned in the introduction, Glove, Penning et al. 2014, scaled word vector representation learning to all of Common Crawl. So it's not representation learning, it's word vector representation learning to all of Common Crawl. An influential early work in deep representation learning for text was skip thought vectors, Kairos et al., McCann et al. 2017, that I'm not familiar with, explored the use of representations derived from machine translation models, and Howard and Reuter et al. 2018 improved the RNN baseline tuning approaches of Dai and Lee 2015. Kanyu et al., again with the incorrect parenthetical choices, studied the transfer performance of representations learned by natural language inference models, and Subramanian et al. 2018 explored large-scale multitask learning. Ramachandran et al. 2018 demonstrated that sequence-to-sequence models, seek-to-seek models, benefit from being initialized with pre-trained language models as encoders and decoders. More recent work has shown that LM pre-training is helpful when fine-tuned for difficult generation tasks like chit-chat dialogue and dialogue-based question-answering systems as well. Okay. Just a bunch of neural models, and we tried stuff and we added more data and we added more pre-trained information. Discussion. Much research has been dedicated to learning, understanding, and critically evaluating the representations of both supervised and unsupervised pre-training methods. And there's citations in there. Our results suggest that unsupervised task learning is an additional promising area of research to explore. These findings potentially help explain the widespread success of pre-training techniques for downstream NLP tasks, as we show that, in the limit, one of these pre-training techniques begins to learn to perform tasks directly without the need for supervised adaptation or modification. Okay. On reading comprehension, the performance of GPT-2 is competitive with supervised baselines in a zero-shot setting. However, on other tasks such as summarization, while it is qualitatively performing the task, its performance is still only rudimentary according to quantitative metrics. While suggestive as a research result, in terms of practical applications, the zero-shot performance of GPT-2 is still far from usable. Agreed. We have studied the zero-shot performance of web text LLMs on many canonical NLP tasks, but there are many additional tasks that could be evaluated. There are undoubtedly many practical tasks where the performance of GPT-2 is still no better than random, like many of the ones they evaluated. Even on common tasks that we evaluated on, such as question answering and translation, language models only begin to outperform trivial baselines when they have sufficient capacity. While zero-shot performance establishes a baseline of the potential performance of GPT-2 on many tasks, it is not clear where the ceiling is with fine-tuning. On some tasks, GPT-2's fully abstractive output is a significant departure from the extractive pointer network-based inputs, which are currently state-of-the-art on many question answering and reading comprehension datasets. I believe, I've been to a couple talks on this. It's sort of like you're looking at the text and you're sort of figuring out where in the text is the most important, and you move your pointers along to be like, this is the one, this is the word that's the most important, so we're going to pop that one out. Is my memory from the conference I went to last year. Given prior success of fine-tuning GPT, we plan to investigate fine-tuning on benchmarks such as Deca NLP, that's what BERT was done on, and Glue, BERT was done on Glue, not Deca NLP, especially since it is unclear whether the additional training data and capacity of GPT-2 is sufficient to overcome the inefficiencies of unidirectional representations demonstrated by BERT. So BERT is proposed a bidirectional architecture that outperformed the unidirectional architecture, and they're saying that maybe if we just make it bigger, the unidirectional architecture is going to perform as well as the bidirectional architecture. Conclusion. When a large language model is trained on a sufficiently large and diverse data set, it is able to perform well across many domains and data sets. That's not what you proved. That was not your results. It kind of doesn't do abysmally on some of them. GPT-2 zero shots to state-of-the-art performance on 7 of 8 language modeling datasets. So a really big language model does better than a smaller language model. The diversity of tasks the model is able to perform in a zero-shot setting suggests that high-capacity models trained to maximize the likelihood of a sufficiently varied text corpus begin to learn how to perform a surprising amount of tasks without the need for explicit supervision. I think begin to learn is a nice way of putting that. Acknowledgements. Thanks to everyone who wrote the text, shared the links, and upvoted the content in web text. Many millions of people were involved in creating the data that GPT-2 was trained on. Also thanks to all the Googlers who helped us with training infrastructure, including Zach Sohn, JS Real, Jonathan Hu, Russell Power, Yulong Chang, Noam Shazir, Solomon Boulos, Michael Banford, Aman Gupta, Daniel Sohn, and many more. Finally, thanks to the people who gave feedback on the drafts, Jacob Steinhardt, Sam Bowman, Jeffrey Irving, and Madison May. I don't have strong intuitions about some of these names, but I think it's possible that no women were involved in the writing of this paper. All right, and then some references. And then additional results. So a lot of these are just sort of like things that they spit out and examples on questions, and I would be shocked if these weren't cherry-picked all the heck. So they picked like the best possible thing to highlight their system performance, which, I mean, makes sense. Everybody does that. And Appendix A, samples. They show blah, 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 blah. Okay, so I don't think this is all just description of the samples. Model capacity. To complement the reported perplexity gains of bigger LMs on web text shown in Figure 4, tables 7 through 11 show side-by-side completions of the smallest web text LM and GPT-2 on random unseen web text test set articles. So just like, how good of a language model is it? Text memorization, we observe some memorizing behavior in GPT-2 on longer strings that are repeated many times in the dataset, such as famous quotes or speeches. For example, when conditioned on the first sentence and a half of the Gettysburg Address, which occurs approximately 40 times throughout web text, an argmax decode from GPT-2 recovers the speech. That's not surprising. Repetition of whole sentences is extremely rare in natural language. Even when sampling without truncation, we find that the model copies the speech for a while before drifting, albeit in a similar style. It typically drifts within 100 to 200 tokens and displays widening diversity once it drifts. To quantify how often exact memorization shows up in samples, we generated samples from GPT-2 conditioned on web text to test set articles and compared the overlap rate of GPT-2's generation to the overlap rate of ground truth completions. The results of this analysis are shown below and suggest that GPT-2 repeats text from the training set less often than the baseline rate of held out articles. CDF, cumulative density function, of the percentage of 8-gram overlaps with web text training set for both web text test and samples, conditioned on web text set, with top K truncated random sampling with K equals 40. Most samples have less than 1% overlap, including over 30% of samples with no overlap, whereas the median for test set is 2.6% overlap. So the samples are generated, and they're saying that there's less overlap than between the real sentences. I don't know what they're having overlap. Andy says possibly GPT-2 would be very good at internet trolling, especially if it was trained on datasets, web pages that contain trolling, which, given the source material, I would not be surprised by. Table 12 shows multiple completions of the same random web text set context, showing the diversity of completions with standard sampling settings. And Table 13 shows the previously mentioned Talking Unicorn news article. We find the model to be capable of handling out-of-distribution context, but the quality of these samples is generally lower. Okay, so yeah, they're saying, like, we picked a good one. So, there isn't actually discussion of this in the article that I saw in the paper itself, but they didn't release the full model, and their rationale was that they didn't want people to use it for nefarious purposes, like generating trolling, like Andy mentions. I think they probably talk about it in the blog post, but this is the paper reading group and not the blog post reading group. Yeah, I mean, I've been thinking about this paper a lot, and I appreciate where the authors are coming from. They're machine learning researchers. They're interested in pushing the boundaries of what neural networks can do with regard to language. I don't get the feeling that this paper was written by researchers who have a deep appreciation for and understanding of what makes language special as a type of data. Ryan says, still reasonable for them to withhold the large model. I mean, kind of not the standard in the field, for sure. This is a departure. I'm really glad people are thinking about ethical implications, and the sort of like good way of looking at this is that they were like, hey, we don't want to be responsible for people doing nefarious things. And the bad way of looking at this is that maybe if they release the model, people will try evaluating it on more tests and be like, actually the model is very bad. But also, like, the results that they reported for the sort of like wide variety of tests that they did, like after we stopped looking at things that were specifically designed for language models, they're not good. Like, they're certainly not state of the art, and they're not better than like a very reasonable baseline that you might give an undergrad as like a class project, you know? So I think this is an interesting paper in that, again, it sets a new high water mark for like how much you can get from just throwing spaghetti at the wall. But this, especially like these generated things. So this is their sort of like generated samples that they're really, really excited by. And it's not a model that contains meaning, right? It doesn't have any understanding of the data set. It has sort of like knowledge of statistical associations between things that are talked about in articles that would be linked to from Reddit. And that's sort of what it's got. And it almost reminds me of, I think I mentioned this on Kaggle Noobs. It reminds me of Wernicke's aphasia, right? So Wernicke's aphasia, let me see if I can get a real good example. Pew, pew, pew. Wernicke's aphasia. Oh no, E-R? Yeah. Is a type of aphasia where you don't understand the content of language. Like, you don't have access to semantic information, but you do still produce like fluent speech. Like your patterns of speech sound like reasonable, like you're produced by just like a person without aphasia, except the meaning and the understanding there isn't correct. So not being able to truly understand the meaning of things, not being able to retrieve target words. So like if you're like, oh, I know, like, oh, it's a bird and it's small and it's like red, but you don't know the word cardinal and you can't get that one out. It flows, like the use of like articles and small things are good. It doesn't have it makes up new words or combines words that don't necessarily occur together that often, like in the world, which I think is less of a problem with this particular model, specifically because it is a language model, so it's conditioned on the probability of words occurring together in the world. And there's just no concrete way of encoding meaning and thinking about meaning, and that's so important and core and central to language. And like the thing that I don't like about Blue is it doesn't capture meaning. It doesn't penalize you for changing the meaning of the input and giving out a good, lots of like all the particles in the right place but wrong meaning output. And then other stuff. I think also repetition is a thing that happens in Wernicke's aphasia, where you just sort of like repeat things. So it's not producing language in the way that a human does, and that's, to me, that's the goal, right? Anyway. Ryan says, I'm looking at the Glue benchmark, and it's interesting that almost every model gets 6.51 why no grad. I wonder if there's some hurdle there. I don't know. I mean, it's hard, right? Abhinav says, it's possible to make a neural network that produces new neurons as per need. Oh, I guess like in theory. I'm not, I'm more up to date on the NLP literature than I am in sort of like the machine learning is a field literature. So someone else might know and can hop in the comments there. And Jared says, the fact that the difference between GPT-2 and GPT-2 is only the size makes me restless. Yeah, that's the other thing that bothers me about this paper. So they're big, like the big, what's the word I'm looking for? I don't have aphasia. The big like contribution of this paper is their data set, right? Is the data set that they put together, web text, which I don't think that they have released. And also, this is it. That's all that they spend time talking about in the data set. I have so many questions, like I have so many questions about this data set and the distribution of the data set, and people have been trying to reverse engineer it on Twitter and not having very good results. Yeah. Andy says, it has learned to BS, but not to think. Yeah, it's not, I don't know, when this paper dropped, there were a bunch of news articles that were like, Facebook has released an AI so dangerous, has developed an AI so dangerous they can't release it. Like, this is not intelligence, right, in the sense of the way that we tend to think about intelligence as humans. And I don't think it's a bad engineering paper. I think it's, sort of an interesting direction. If you have to do a lot of different tasks, I think it could, for some people, end up being more efficient, but most people are looking to do a specific task in NLP, right? Like, they have one thing that they want to do for whatever it is that they're doing. And if you could use a generalized model like this as sort of a jumping off point, that would be great, but they didn't release the model. Yeah. I don't know, and it's really not in discussion with the linguist. No, I mean, most NLP papers aren't in discussion with the linguistics literature, let's be real, but it's not in discussion with the NLP literature. It really feels like a machine learning paper where they were like, hey, text is interesting, let's you know, throw some tech spaghetti at the wall, which, and I don't have necessarily a problem with people coming in from outside of the field. I think that that's great and brings richness and vitality and new ideas and shake things up. But I feel less good about it when people come into the field without a background in the field and don't sort of like spend a little bit of time getting their footing and their grounding and figuring out what people are already doing and what approaches are working. And it feels like they didn't do that. Like if this were a chapter that an advisee had given me, I'd be like, where's the lit review? This is not an appropriate literature review. Just go back and try it again. Not that I have advisees, but scooch so my little shield is all in frame. Yeah. I don't think it's a bad paper. I think that the generation results are interesting. We don't have a good way as a field of evaluating generative text results. So, and that might be changing. I mean, the ACL deadline just passed, so maybe someone has like dropped like the fabulous text generation evaluation metric that everyone's going to be using next year. Who knows? But yeah, I feel like this is sort of we tried a bunch of stuff paper. I don't think that the main contribution, which is, I consider it to be this data set, is discussed in enough detail. I don't want to say that people shouldn't release models that they think are going to cause problems later on. I think that that's a very reasonable thing to think about, and I applaud them for thinking about that. I'm not sure that this model will cause problems, because there are lots of ways to generate text that, again, we don't have a great way of evaluating it, but the sort of like sound okay. Like I think everyone who's sort of like been interested in NLP at some point in the past probably did like the little Markov chain text generator thing. Like I think I have, what was my first one? I think I wrote one to generate my own blog posts. I trained on my blog post data when I was in grad school. I think I did one to like generate paper titles or something. There's one that was going around linguistic circles a while ago that was like a mix-up of Noam Chomsky and the Bible. So it was like generating, Noam Chomsky is a very famous linguist and political scientist who made a lot of contributions to the field of syntax. So that was sort of like a fun thing. But I think that they should have submitted this paper to peer review, and if they did submit it to peer review and the peer reviewers were like, then maybe they should have paid more attention to those peer reviewers. I don't know that that was the case or not. I'd like to see more discussion of the NLP literature, and also just like a bigger contribution. Like I consider web text to be like, that's interesting, that's cool. You didn't release it and you didn't really go into too much detail. Like that could be an LREC paper all on its own. So, and I don't want to like, I don't know, I feel like there was much more richness and many more new ideas in the BERT paper, and I don't want to be like, BERT's from Google, I work for Google, Google's great. Like I don't want to like have that sort of like impression. I wanted to give this paper a fair shake, but I'm not delighted by it. I don't think that we've solved NLP, and I don't think that this paper shows that we'll be able to solve NLP using just bigger models and more data. I'm sort of unconvinced. So, yeah. So it's 10. I'm going to start calling it now. Abhinav says, is it possible to read text from a video? I'm not super familiar with video processing, but I know it's hard, so I would ask. Oh, Ryan says, as a non-academic, what is the value of peer review versus just sharing what they found? So the value of peer review is that one big thing is that people who know about related work that you're not familiar with can point you to it, so that you are entering into that conversation. Another thing is that people can point out sort of like holes in your work. I think that there's nowhere near enough description of the data set, especially considering that, again, that is the contribution of this paper. I mean, it's just like sort of an outside pair of eyes on your work that has deep understanding of the field that you're working in, and can give you feedback, and help you to strengthen your work. So it's sort of like, it's similar to code review. if you're doing a code review where you're not focusing on syntax and you're really focusing on like, hey, there's a bug here. Like it's finding bugs in your thoughts, basically, is the peer review at its best. Yeah. All right, and with that in mind, I am going to call it a day. I will see you guys on Friday for live coding, which I'm really looking forward to. And hopefully we'll have camera set up going forward on this computer, because my new computer can handle it, and it's so nice. And I will talk to you guys then on Friday. Bye, have a great week.